The next logical step in chemistry is to look at molar mass, and that's what we're going to cover today in section 8.5. By definition, molar mass is the mass in grams of 1 mole of a substance. So this information, for example, the molar mass of nitrogen, is what we receive from the periodic table. So you look up nitrogen, you look at the mass on it, and it's 14.01, and we can look at that as the number of atomic mass units per atom. Or in this case, if we want to know the molar mass, the mass of 1 mole, then we say that that's 14.01 grams per mole. So what if we have a situation like this where we want to know the molar mass of water? We no longer have just one element, we have more than that. And you're going to set it up like this. Again, there's a method to the madness, so you need to make sure that you pay attention and write down the problem just like I do it. We're going to start with writing down each element that we have. So we have hydrogen and we have oxygen. We write down the number of each, so we have 2 hydrogen and we have 1 oxygen. Then we look at the molar mass of each element. So the molar mass of hydrogen is 1.01 grams per mole, and we know that oxygen is 15.998, I believe, so we're going to say it's 16 grams per mole. Then we're going to go ahead and multiply those out. So 2 times 1.01 is 2.02. Oxygen is going to be 16.00. So the molar mass of water, H2O, is 18.02 grams per mole. And I know that this would be really simple to throw in a calculator, and that's going to be what's tempting you, is to put that in a calculator and not write this information down. But this is the information I need you to write down in order to do the problems correctly, and unless they are set up like this, you get no credit for your answer. So make sure you take time to do that. All right, so let's take a look at how to set up another one. And if you notice here, this is the way that the answer is shown for this set of slides that I chose to use for this. But the way that I worked this one out is the way I expect you to have each one of them worked out. So let's do the molar mass of barium nitrate. So we start off with barium, and we have 1 of those. And we have nitrogen. Now there's 1 nitrogen inside of this nitrate ion, but there are 2 nitrate ions. So 2 times 1, so we have 2 nitrogen. Oxygen, we have 3 in each one, and there are 2 total, so 2 times 3, so we have 6 oxygen. So we have 6 times 16, we have 2 times 14.01, and the mass of barium is 137.33. So we just bring these over, and yes, you have to show your work. 0.02. The oxygen is a total of 96, and we're going to add all of these up, and we come up with 261.35, and the units are grams per mole. So if I have 1 mole of barium nitrate, it's going to weigh 261.35 grams, which is everything that's included in it added together. Just like with the water, that is 18 grams for 1 mole of water, and nitrogen by itself 14.01 grams per mole. So doing the molar mass is a really, really simple procedure, but it's one that you have to show all of your work to get the credit for, and we have to have a reason behind it. So let's go on and look and see why we need to know about molar mass. For the first example, what we're going to do is to read a question out of the textbook. So the one that I'm looking at is example 8.7 that's found on page 222, calculating moles from mass. And it says juglone, a dye known for centuries, is produced from the husk of black walnuts. It's also a natural herbicide, and it kills off competitive plants around the black walnut tree, but does not affect the grass and other non-competitive plants. The formula for juglone is C10H6O3. They want us to calculate the molar mass of juglone. So let's start off by doing that. So we have carbon. So we have 10 times 12.01. We have hydrogen, which is going to be 6 times 1.01. We have oxygen, which is going to be 3 times 16. Got ahead of myself there. And we're going to get a total mass. So this is going to be 120.1 grams here. This is 6.06 there, and we have 48 grams here. So when we add all these together, we come up with a total of 174.16 grams per mole. So there's the molar mass of the juglone. Now the next question they ask is, they have a sample of 1.56 grams of pure juglone. It was extracted from black walnut husk. How many moles of juglone does this sample represent? So before we had our roadmap, we have grams to moles, and we have moles to molecules or atoms. And remember that we talked about how this is this way, and this is the pathway that you have to go. So if I want grams to molecules, I have to go through moles. Moles to grams, you have to go through moles. I'm sorry, molecules to grams, you have to go through moles. So where we're at is at grams, and we want to get to moles. So what we're going to do is we're going to take, instead of the individual masses, we're going to take this molar mass and put 174.16 grams over 1 mole on top, and do the math that's going to allow the grams to cancel. So we're going to take 1.56, multiply it times 1, divided by 174.16, and the number of molecules, I'm sorry, the number of moles should be 0.00896 moles. That's a thousandth or smaller, so we're going to put that into scientific notation. 8.96 times 10 to the negative third moles of juglone is our answer. So that's our final answer on this problem. And those are kind of problems we're going to be looking at throughout this next section. We're going to take a look at one more problem before you get started on your homework. Calculate the number of molecules. Here's another example. It's in your textbook on page 223. It says isopentyl acetate, which is C7H14O2, is the compound responsible for the scent of bananas. It can be produced commercially. Interestingly, bees release about 1 microgram of this compound when they sting. This attracts other bees, which then join the attack. How many moles and how many molecules of isopropyl acetate are released in a typical bee sting? So we need to know, first of all, what the molar mass of this substance is. So we're going to start by writing down what we've done before, and we're going to multiply that all out times 16. And through the wonders of technology, you can see those already written out for you, and that's going to total 130.21 grams per mole, and that's the molar mass of this substance. Now we're going to go back to the original problem, and it says that bees release about 1 microgram of this substance when they sting. And we know that this is 1 times 10 to the negative 6 grams. So what we're going to do is we're going to change grams to moles. So we don't know how many moles that is, because we want to know how many molecules are actually being released. And remember, I have to go grams to moles and then moles to molecules. All right, so we're going to use the molar mass. So it's going to be 1 mole is 130.21 grams. That's going to give us an answer in moles. This will be 7.68 times 10 to the negative 9th moles. And it also wants to know the number of molecules. So we're going to take 7.68 times 10 to the negative 9th moles, and we're going to change that to molecules. So we know that the conversion is 6.022 times 10 to the 23rd molecules per 1 mole. We can cancel those out. We multiply that. 323, and we have the number of molecules as 4.62 times 10 to the 15th molecules that are being released with each bee sting. And that's your final answer. Remember, you can always refer back to the videos to make sure you're setting up your problems correctly. All of this is still necessary even with a problem like this. So show your work, because no work equals no credit. You don't want to go through all that trouble and not receive credit for it. So like I said, review if you need to. Make sure you've taken notes over this so that I can help you in class with it as well.